will make sense. Most of the things will make sense. So now, let's start with the horizontal, because now the horizontal plays a very important role in Newton's law of motions, okay? So on the horizontal, what we can say is that the vertical resultant it's equals to 0 newtons. The vertical resultant is equal to what? 0 newtons. Exactly. So now we're going to use what? We're going to use the horizontal. We're going to use the horizontal resultant. The horizontal resultant will be the one that determines the acceleration. This is very important, okay? Right. So now, based on what we learned on the previous session, let's say that we're going to have a force that is pulled at an angle, okay? A force that is pulled at an angle. So now I'm going to put down the drawing here where the force is pulled at an angle, because there are some of the things that we need to highlight. So if the force is pulled at an angle like this, we know that this will be our theta. So now let's try to draw the free body diagram of all the forces that are acting on this object. We said we're going to have the force that is going up. And what is that force? Then exactly the normal force. Then we have a force that is going down. What is that force? Fg. Exactly. So now we said that if the force is pulled at an angle, this is my applied force. Where is the friction going? In an opposite direction. The friction will go in that direction. So this is my F. Are you happy with that? Okay, so now in an exam, they'll ask you to draw a free body diagram. This is what you're going to do. When you draw a free body diagram, remember that we're going to say from this starting point, we're going to pull a force away. And we said, what do we call that force? Fx, exactly. And now we're going to do another force that will be head to head with the applied force, and we said we'll call that one Fy. So the free body diagram, we just have our Fn. These are the forces that are vertical forces, and our Fy. Then we have the force that is going down, which is Fg. Then we have the Fx going that side, and we have the frictional force in that form. You understand? Okay, the reason I want us to draw the free body diagram, the reason why I wanted us to do the free body diagram is because I need you to understand the horizontal and the vertical. You understand? So let's start with the vertical, because this is what we already did. Remember the vertical, we just said that the vertical resultant is what? It's 0. So this tells me that we're going to say all the forces that are acting. Let's choose direction. Maybe we can take up as positive, okay? So if we take up as positive, all the forces that are going up, we add them, Fy plus Fn. Then what do? We subtract all the forces that are going down and equate this to 0. Why? Because F net, it's equals to 0. Are you with me on that? So now, for now, we're going to leave this like this. We know that if we are working with vertical force, this is the formula that we're going to work about. But what about the horizontal? Remember, the horizontal is Newton's law. So F net will be equals to ma, okay? We need to identify the horizontal forces, which we only have the two horizontal forces, which is the Fx and what? And the F of frictional force. So what you're going to do with that information, you're going to say, okay, we choose the direction of the motion as positive. So Fx will be positive. So I'm going to say this is my Fx. Fx, we minus our frictional force, equate this to ma. So now, I don't want you to make mistakes. Remember, if the force is pulled at an angle and they ask you a question, whatever question they ask you, if they want you to find the frictional force, this is the formula you use. If they want you to find the acceleration, this is the formula to use. Because now, why is Newton's law? Why do we make mistakes on Newton's law? Because of arranging this formula. So if you can manage to know that if the force is pulled at an angle, this is the formula for Newton's law. Whatever they want you to calculate, use this formula. So now, okay, so now you're going to ask yourself, how will this work, the vertical forces? You'll see when we do example, maybe we can use this to find the normal force, and you still remember what was the normal force, okay? Okay, so now let's assume and say that the force is now pushed at an angle. I think now you already know what will be there. I think you already know. So now a quick tip. If the force is pushed at an angle, okay, let me draw the force here. Okay, here is our diagram, and it's going like in that direction. Okay, I'm sorry, the force is pushed at an angle, so it's like this. It's like this. Okay, so now remember the Fy this time is going down, and the Fx will go in that direction. Okay, this is my Fx. So now we have the normal force going up. What else do we have? We have the Fg, but now pay attention. The force is pushed. So if the force is pushed, it's going to move in that direction, which will make the frictional force to go in that direction, in an opposite direction. Can you see that? So now if we do the free body diagram, we know that the frictional force will move in that, the Fx in that direction, the frictional force in the other opposite direction, and we have Fg going down, and we have Fn. Okay, Fn going up, Fg and Fy going down. Okay, this is what you have. So now we're saying that the horizontal force and the vertical resultant. The vertical resultant is the one that is 0. We choose direction. So let's say we take up as positive. So we take up as positive. So all the forces that are going down are going to be minus. So we're going to minus Fy, we minus Fg, and we equate this to 0. So remember, the force that we are currently discussing is for the what? Is for the vertical forces. You understand? So now you need to also do for the horizontal. Okay, so a quick tip, the horizontal will be the same as this one, because still the force of friction and the horizontal component, they go in different direction. So what we're going to do is that we can say, just to be not confused, we always will choose the direction of the positive, the direction of the motion as positive. So it's always like Fx minus the frictional force is equal to ma. So for the horizontal, the force is pushed or it is pulled, we're going to use the same formula. Are you with me on that? So the difference will be between the vertical forces. So I'm going to show you how to apply these forces. Are you happy with that? Okay. Okay, and that's for the what? That's for the horizontal. That is for the horizontal. Okay, That's the force. You're going to see when we work on example, how are you going to use this information to answer our questions. So tell me, based on the forces that we worked on, do you have any question? Because now, in order for you to understand Newton's law, you need to understand whatever that we are currently talking on this 10 minutes lesson. You understand? 100%. Okay, good.